This conversation is powered by Google Illuminate. Check out illuminate.google.com for more. Today, we're diving into a paper that tackles a common challenge in natural language processing, handling long input sequences. The paper, Writing in the Margins, Better Inference Pattern for Long Context Retrieval, proposes a novel approach called Writing in the Margins, WIM, to improve the performance of large language models, LLMs, on retrieval-oriented tasks. What's the main issue that WIM addresses?
The core problem WIM tackles is the performance degradation of LLMs when dealing with extensive input sequences. This limitation stems from their fixed context window and attention mechanisms, which struggle to effectively process large amounts of text. As a result, LLMs often struggle with tasks involving long contexts, especially when the relevant information is buried within a vast amount of text.
So how does WIM address this challenge of processing long contexts?
WIM leverages a technique called chunked prefill, which is commonly used to prefill the key value KV cache of LLMs in a segment-wise manner. This approach divides the long context into fixed-sized chunks and processes them sequentially, reducing memory usage and computational overhead. WIM takes this a step further by introducing the concept of margin notes.
Margin notes, that sounds interesting. Can you elaborate on how they work?
During each chunk processing step, WIM prompts the LLM to generate an extractive summary of the current chunk, focusing on information relevant to the task at hand. These summaries are called margin notes. The model then classifies these margin notes as either relevant or irrelevant to the task. Relevant margin notes are then appended to the context before the final instruction, effectively providing the model with a condensed version of the key information from the long context.
So the margin notes act as a kind of distilled version of the long context, helping the model focus on the most important information. How does this approach impact the performance of LLMs?
The paper demonstrates that WIM significantly enhances the performance of LLMs on various long context retrieval tasks. For example, it shows an average improvement of 7.5% in accuracy for multi-hop reasoning tasks like HotpotQA and MultiHop-RAG, and a 30% increase in F1 score for aggregation tasks like CWE.
That's a substantial improvement. Can you explain why WIM is so effective?
WIM's effectiveness stems from several factors. First, it helps mitigate the issue of mid-sequence forgetting, which is a common problem in LLMs when processing long sequences. By providing the model with a condensed version of the key information through margin notes, WIM helps the model retain important context throughout the processing. Second, WIM allows for a more efficient use of the KV cache, as it only stores relevant margin notes, reducing memory usage and computational overhead.
It seems like WIM not only improves performance, but also enhances the user experience. Can you elaborate on that?
Yes, WIM offers several benefits for users. First, it provides transparency into the model's reasoning process by displaying the generated margin notes. This allows users to understand how the model is processing the information and identify potential issues. Second, WIM can reduce latency by providing relevant information during processing, allowing users to get a sense of the model's progress and potentially exit early if they find a satisfactory answer within the margin notes.
That's a very practical benefit. It seems like WIM opens up possibilities for human in-the-loop interaction with LLMs. Can you elaborate on that?
Absolutely. WIM's design allows for user feedback on the generated margin notes. Users can label the margin notes as relevant or irrelevant, and this feedback can be incorporated into the final decision-making process. This creates a more interactive and collaborative approach to using LLMs, allowing users to guide the model's reasoning and improve its performance.
This is a fascinating concept. It seems like WIM is a significant step forward in addressing the challenges of long context processing in LLMs. What are some of the potential future directions for this research?
There are several promising avenues for future research. One area is to further optimize the computational efficiency of WIM by exploring different KV cache management strategies and segment sizes. Another area is to investigate the potential of fine-tuning LLMs, specifically for the extraction and classification tasks involved in generating margin notes.
It seems like there's a lot of potential for further development and refinement of WIM. Can you discuss how WIM compares to other approaches for handling long contexts in LLMs?
WIM stands out from other approaches in several ways. Traditional methods like external memory augmentation and retrieval augmented generation, RAG, rely on external knowledge sources or retrieval mechanisms to access relevant information. WIM, on the other hand, operates entirely within the LLM itself, leveraging the KV cache and prompting strategies to extract and integrate relevant information.
So WIM is a more self-contained approach, relying on the LLM's own capabilities to handle long contexts. How does WIM relate to other techniques like scratchpad mechanisms and context aggregation methods?
WIM shares similarities with scratchpad mechanisms, which involve recording intermediate computations to improve the model's reasoning abilities. However, WIM focuses on extracting and integrating relevant information from the long context, while scratchpad mechanisms are more focused on recording the steps of a computation. WIM also complements context-aggregated methods like fusion in decoder, FID, and MapReduce, which aim to efficiently combine information from different segments of the context. WIM provides a mechanism for identifying and prioritizing relevant information before it is aggregated.
It seems like WIM offers a unique combination of features, drawing inspiration from various existing techniques. Can you summarize the key contributions of this paper?
The paper introduces WIM, a novel inference pattern that significantly improves the performance of LLMs on long context retrieval tasks. WIM leverages chunked prefill and margin notes to effectively handle long contexts, mitigate mid-sequence forgetting, and enhance the model's reasoning abilities. Furthermore, WIM promotes transparency and user interaction, allowing users to understand the model's reasoning process and provide feedback.
This is a very promising approach. It seems like WIM has the potential to significantly impact the way we interact with LLMs and handle long context tasks. What are your overall thoughts on the paper and its implications?
The paper presents a compelling and innovative approach to addressing the challenges of long context processing in LLMs. WIM's ability to improve performance, enhance transparency, and facilitate user interaction makes it a valuable contribution to the field. It opens up new possibilities for developing more efficient and user-friendly LLMs that can effectively handle complex tasks involving extensive input sequences.